Hello scholars, welcome back to the channel. We're going to be looking at integers. What are integers? So integers are the negative and positive whole numbers and zero. We can represent integers using the number line. So here we have the number line, center at 0. To the left of 0 we have the negative numbers, and they continue towards negative infinity. That means on and on and on and on. Infinity is not a number. Infinity is a concept, which means that the numbers keep going on and on and on. To the right of 0 on the number line, we have our positive whole numbers, and they too continue towards positive infinity. On and on and on, they keep getting bigger and bigger and bigger, ad infinitum, on. So we can never get to the end of numbers. It doesn't matter which direction we go. So, to the left of the 0, the numbers keep getting smaller. But you might say, but 5 is bigger than 4, right? 5 is bigger than 2. So how are we saying that the numbers are getting smaller? Well, 5 is bigger than 2, but negative 5 is smaller than 2. Negative 5 is smaller than negative 2. So all negative numbers are actually smaller than 0. Negative 5 is a much smaller number than 0. Negative 8 is a much smaller number than negative 5. So even if the digits themselves are bigger, once there's a negative sign there, it's actually a smaller value. It has a smaller value than the positive numbers or than the negative number with a smaller digit. So you can use that as a guide, right? For negative numbers, once the numbers are negative, the bigger the digit, the smaller the number. So negative 200 is a smaller number than 6, or it's a smaller number than negative 6, right? So use that as a guide. All negative numbers are less than 0. But you might say, well, 0 is nothing, right? So how can we say something is less than 0? Well, how do negative numbers come in? There are actual real-life applications for the concept of negative numbers. So, for example, temperature. When we're calculating temperature or we're reading temperature from a thermometer, right? The temperature keeps getting less and less, so it's getting colder and colder. We actually have negative temperatures that are below 0. So 0 degrees Celsius is the freezing point. That's when water starts to freeze. But we have temperatures that are even colder than that, and we say they are minus 0, below 0, right? So negative 5 degrees is much colder than 0 degrees. So the idea of losing value, getting less, that's a concept of negativity. Right? Once we're losing, we're taking away, and we can get to the point of 0 and still be taking away. So for example, another example, if you have money in your account, so let's say you have $20 in your bank account, and you go to the ATM and you withdraw some money, right? So let's say you withdraw $20. You have $20, you took out $20 from the machine. So $0 are left. However, you forgot that there's a charge. Let's say the bank charges you $1. Each time you do a transaction, the bank charges you $1. But you didn't remember to leave that $1 in the account so that the bank will take that charge. You just knew you had $20, you need $20, and you withdrew that. So in your mind you have $0, but the automatic process of taking that fee, that $1 fee, will be deducted, withdrawn from the system in payment of that transaction. So you would actually have now a negative balance. You would have a negative $1 on your account, which means you owe the bank $1. So you personally have no money in there, but you still owe $1 for that transaction fee. So as soon as you lodge more money to the account, that $1 will be deducted, actually deducted, but it's reflecting the deduction already on the account as a negative balance, right? So those are two examples. Temperature, where we can go below zero, and money in the account, where in some instances you can withdraw more than is there because of how the system works, the timing. So you didn't remember that the fee is due, you took out what was there, but the fee is still applied. So now you have a negative balance. You actually owe the bank, right? So those are two examples of how negative numbers apply. So they're not, so it's almost as if it's theory. It's theory, right? Because remember, the counting numbers, the actual natural numbers start at 1. And 0 represents nothing, right? But in theory, we can think of losing what we don't even have as yet. In theory, right? Just like we can withdraw money that's not even there on paper in the system. So that's how negative numbers come in. And in real life application, they really count. Negative numbers count. So when I say count, I mean they make a difference in terms of calculations, right? So let's look at some rules though. So the integers are negative and positive whole numbers plus 0. 0 is an integer as well. And we like to think of 0 as being midway between the two infinities, right? Halfway between, even though infinity is not a number, it's a concept. Halfway between the infinities, we have 0. When we are adding on the number line, when we are adding, we move to the right. So we move that way when we're adding. When we're subtracting, we move to the left. Alright? And additive inverses cancel each other out. What do we mean by additive inverses? If we're adding 6 and taking away 6, those are inverse operations to each other. 6 minus 6, that's 0. They cancel each other out, they get 0. Or negative 6, we could start with the negative 6 and then add the 6. So negative 6 plus 6 gives 0. So those are called additive inverses. When you're adding a number and subtracting that same number from itself, you will get 0. Alright, now just bear these in mind. These operations having to do with negative and positive integers. A negative integer times a negative integer will give a positive integer, right? So negative times negative give positive. Likewise, negative divided by negative gives positive. So a negative 8 divided by a negative 4 will give a positive 2. And negative 8 times a negative 4 will give a positive 32. But negative times positive give negative. And we know positive times positive give positive, because positive numbers are what we work with normally. On an everyday basis, the numbers we work with generally are positive. So we know when we multiply them, we still will get positive results. So let's work these integers. We can use the number line. So negative 4 plus 4. So we start at negative 4. We're adding 4. So we move 1, 2, 3, 4 places, and it takes us to 0. Like I said, these are additive inverses. So adding 4 to negative 4 would give 0. Taking 4 from positive 4 gives 0. Same operations. 6 take away 8. So if we start at 6 and to subtract we move to the left. So 6 take away 8. 1, 2, 3, 4, 5, 6, 7, 8. That takes us to negative 2. 2 take away 10. So starting at 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's negative 8. So do you notice it's as if we can just subtract the smaller one from the big one and make the answer negative. If we're taking a bigger number from a smaller one, just do the subtraction as normal, take the smaller from the bigger, and the answer will be negative. 3 take away 5. So 3, 1, 2, 3, 4, 5, that's negative 2, and then we add 4, 1, 2, 3, 4, that's positive 2. 6 plus 8, we know that's 14, take away 10, that's 4. Here we have our additive inverses again, 5 take away 5, we know that's going to give 0, and then we add 5 again, that's going to give us back our 5. So 5, you take away the 5 and you add back the 5, you end up back with 5. 9 take away 11, so 9 from 11 is 2, so that's negative 2. Remember we said we can just subtract and make the answer negative. 4 plus 8 is 12, minus 12, that's additive inverses, so we're going to get 0. 9 take away 10, so 9 from 10 is 1, so that's negative 1. 1 take away 5, 1 from 5 is 4, so it's negative 4. Once you're taking a bigger from a smaller, just subtract the small from the big and make the answer negative. 3 plus 3 plus 3, so those are all positive numbers, which is what we normally work with. We know 3 plus 3 plus 3 gives 9. We know 8 take away 6 gives 2, right? Negative 4 minus 4 minus 3. So we start at negative 4. We keep moving to the left because we're taking away 4 again. 1, 2, 3, 4. And we're still moving to the left 3 more places. So that will take us to negative 11. So this is another pattern. If you start with a negative number and you keep subtracting, add the digits and make the answer negative. Negative 1 minus 5 then will be negative 6. And then we add 10. So negative 6 plus 10. We can actually do the plus 10 first and then the minus 6. Same thing. So negative 6 plus 10 is the same as 10 minus 6, which is 4. So we can manipulate our integers for convenience. For convenience, you can just remember the sign goes with the number. So if we're rearranging, that's a positive 10, that's a negative 6. We can rearrange it like that. But remember to take the sign with the number that follows it. So that's it for integers, the negative and positive numbers, and 0. Alright, so if you have been helped by this video, just drop a line to say thank you, miss, and just share the videos so your friends and family members can benefit from the information just like you did. And if you haven't subscribed, please subscribe now. Ask your friends to subscribe, ask your relatives to subscribe, ask your teachers to subscribe. Everybody needs to subscribe. Let me know if you have been looking for a particular video and not finding it. If maybe we haven't done that topic yet. We're going to do all the topics eventually. But if you need something really, really urgent, just let me know and I'll do that topic for you. So take care, scholars. I'll see you in the next video.